Okay. All right. So we have a model of friendship, but of close friendship, excuse me, which is a pretty sparse network. I don't remember looking at the stats, but it's going to be a lot sparser than friend or close friend networks. And we're finding that we get effects that are statistically significant, but a not terribly great convergence of the algorithm. And what that tells me is that the model is either incomplete or it doesn't really address the dynamics in this best friend network correctly. But thinking about the structure of this best friend network, we have to remember that unless somebody is a friend, they're probably not going to become a close friend. I've been using the term best friend, I mean close friend, as we call it in the questionnaire. And it is not unlikely that the dynamics that lead to people being friends, which is to say that they get along okay and they can talk and maybe they tell jokes to each other and stuff, but it's not an especially exclusive, very significant relationship. But if somebody, names someone else as a close friend, it does suggest more self-disclosure, more exclusivity, all of the things we know that are associated with, having somebody who is really a kind of a special friend. And the dynamics associated with creating that relationship could be quite different than the ones that create what we would merely call a friend relationship. But that means that since these two types of relationships are obviously correlated, since one is a subset of the other, right? Friend or close friend clearly is a superset of close friend, in other words. We need to control for the dynamics that create the friendship network in order to disentangle the either similar or maybe quite distinct effects that are creating the close friend network given the friend network, basically. So that's the idea here. That's why we're trying this sort of more complicated approach. And it's a very logical approach whenever your interest is in whether some measured degree or valuation of the network relationship is at issue. So it could be, as we did, in our paper 7 years ago, we looked at sort of different levels of what we call trust in terms of how much money you'd be willing to loan somebody. And we noted that there were some interesting differences in trusting somebody for only this much money, but versus trusting them for a larger amount. And we may find the same thing here. So the hypothesis, the substantive hypothesis that's driving all of this is the idea that the dynamics that are driving friends and close friends relationship formation or change generally may well be different, and that they may therefore also interact with the recovery factor in distinct ways. For instance, it might turn out that once you've controlled for friendship, the close friendship actually is much more intimately connected with the other person's level of recovery as we measure by the recovery factor score. That would be the sort of thing we'd be on the alert for here. And this is what you have to do to find that out. So fundamentally, it's a matter of controlling for the less intimate relationship to see if there are some distinct effects associated with forming the more intimate relationship, and whether therefore those relationships have themselves different kinds of interactions with changes in the recovery factors. Okay?
Great.
That make sense?
Thank you, John.
Yeah. Okay, so shall we go ahead and do this?
Yes.
Let's do this. All right, we've got our new script. Why don't you scroll up to the top there, Ted? And we're going to find the effects object. Excuse me, the data object, sorry. I think you're down another, there we go. Okay, there's our data object, all right.
Right here. Yeah.
So now here we're going to call this dtobj1 dot 2fr. right? To go with the fact that the whole script is different here. But by the way, let me just interject here that, you could conceivably decide that you want to actually make a different and more specialized worksheet, or not worksheet, workspace, other than the one that we've been using by default, which is called base wksp.w12345 6.forall.rdata, right? We could create another one with some of the other variables and stuff that we don't think is going to be relevant here deleted before we save it. But I think I'd rather just try to keep everything together so we don't have to worry about it. It's kind of a pain in the neck if you run into a situation where you want to do something and the object that you need to do it isn't in your workspace, right? I mean, you can always recreate it and put it in it, by simply running whatever script code generated the object in the first place. But as long as the workspace doesn't get too large, you're really fine. And by too large, I would mean like probably up to 20 megabytes. And my guess now is that it's probably more like, I don't know, 3 to 5 meg, I'm not sure. We can see if we can find it in the files window there. And it's just called base workspace dot, no, not the, yeah, down there, right? Base workspace, yeah. Yeah, it's 5 megabytes. Well, that's not tiny, but it's not a problem. And it could be up to probably 10 times that size and we'd still be okay. And so we're not in a place where we have to worry about it. So anyway, that was just a little interjection about, one more thing to worry about.
And that's all the waves and all the data and all the instruments are all in this, right?
As far as I know, at least when I gave it over to you, that was everything, anything that I had ever created that would have any ongoing relevance to me anyway. Although, of course, new and different things are becoming relevant as we're seeing. Like, for example, we're about to create a new data object, which I hadn't created. Well, this would be a good data object to leave hanging around, right? In case somebody else wants to use it, or in case I want to use it. Well, this is going to be in your own branch. But somebody could come conceivably and borrow your workspace if they wanted to later, as long as they didn't write into it. That would be legal. So there can be advantages of keeping it around. All right. So anyway, so this one is all we're going to do here is we're going to add, so we have bfnet0sd as part of the call to Siena data create. Add to that, I would make it first, fnet0sd. Make it the first network. Yeah, just put it in, there you go. There you go. Oops. So just fnet0sd. Great, and click the run button. Grinder. Oh, wait a second. I'm sorry, I forgot something. We're gonna have to do that again, but no big deal.
John, could you just real quickly just go over the variables in this equation, just so everybody knows what they are?
They are, okay, fnet0sd is a friendship network defined by I picks J as a friend or close friend, the way we ask the question. bfnet0sd is a friend is defined as somebody who is a close friend. So a friend in that case would still be coded as a 0 along with all the other lower categories. And only a best friend would get a 1 code, right? And then we have RF as the recovery factor, which is going to be a dependent behavior variable. So the two networks, fnet and bfnet, are both dependent variables in the sense that we're predicting changes in them. And so is RF, but RF will be a special kind. It's not a network, it's a behavior, which is, as we've noted, any kind of mutable that is changing over time characteristic of an individual. And then we have three fixed individual characteristics, which are sex, age, and is in res L, which is the amount of time the person was in residence when they did their first survey with us. And then finally, CCSD is the composition change variable. Okay.
John, just one other question for everyone. Certainly, the recovery factor is changing over the different waves every 4 months, probably. The social networks are also changing every wave. So
Yep.
you really got two things that are changing over time.
You have, well, yeah, basically you have things, the things that can change over time. Right. All right. I'll back up here. Any dependent variable, that is to say, a variable that we're trying to predict changes in, is going to be changing over time, because that's what, stochastic actor modeling is. It's modeling change over time. And it cannot model static changes. Well, I think actually there's ways to fake it so that it can, but there's better ways to do that. Yeah, so you basically have those two network variables, which are dependent, and then you have the recovery factor, which is dependent. You can also have time varying predictors, which are not dependent, which are in other words exogenous. And they're just predictors that are different at every wave. But they don't evolve over the course of time. They are simply variables that could be correlated with the changes, but they change at every wave. And then, at least in this model, everything else is that we have is a fixed covariate, which has only a value in one time period, namely the first, and it doesn't change after that. Okay.
So something that's exogenous could be, for example, differences between winter and summer, which might have effects on these types of relationships.
Right. I'm trying to think of another good example. Well, I'm kind of drawing a blank on that a little bit right now, mostly because I'm thinking in terms of variables that we've actually measured here. But any characteristic of a variable that we that we don't care about having it co-evolve with all of the other dependent variables. You remember how in dynamic models, the thing that distinguishes them from non-dynamic models is the fact that there's interaction. Okay, there isn't just one-way causation. In other words, A causes B, but B can also cause A. A causes C, but C can also cause A. So it's that feedback, and you can have things like A causes B causes C causes A, that type of thing too.
So John, in a sense, for example, the number of people in the community that are test positive for COVID, that could be something that changes over time and could have a direct effect on people's interactions and relationships.
Right. I mean, generally speaking, of course, that's not a characteristic of an individual, but the idea of it changing over time, yes. I mean, that absolutely could be, is the sort of thing that could be a predictor. And actually, you can use that. You could use a variable like that as a variable where, everybody who had a house in a particular community had the same value on it because they share the same environment, right? That would only work if you had enough distinct such environments so that it becomes possible to do statistics on that measure, right? I mean, in the limit, if you had like 20 houses, but they're all in the same community, so everybody has the same environmental variable, let's say the rate of COVID in the community, obviously that is not going to tell you anything. But if you have enough different communities in your study with houses in them, then it can work okay. But that, that's not important. I mean, your general point about what an exogenous time varying variable would look like is exactly correct. Okay. All right. We have one other thing that we have to do here, which I forgot about, and it's the reason that the, hold on 1 second. It's the reason that that data object was not successfully created, which you can tell because, you know, you've got that red bar right next to it. There's a bug in R-Siena, and that bug requires us to change the format of the networks from a list of sparse networks to an array of sparse networks. If you know the difference between lists and arrays, that is transparent what I'm talking about. If you don't, we don't really have to get into it right now. I mean, it's an R thing, and it's just really not that important for us to go into. But we are going to have to figure out how to do that. So give me a second here. And I'm going to find the code where I did that over here. And what I might do, Ted, is I might just email you this code. Because it's easier than trying to dictate it to you.
John, you can put it on chat if you'd like.
I think an email is going to work better in this case. I mean, chat is fine for like a little short thing, but this is like a couple of lines of code, which is maybe a little more than we can really deal with.
On my third monitor, so I should be able to copy and paste pretty quickly.
Just give me a sec here.
Take it down.
Okay. Okay. Okay, I found it. Let me just, would you show me the R-Siena setup model script again, Ted? And let's scroll up a little bit. I want to see what you named the best friend network in preliminary code. Okay. Okay, hold it right there. Okay, great. So BFnet 0, that's fine.
Should have added C.
Did you ever create a bfnet0.sp?
Yeah.
Show me where.
Right here.
Ah, yes, there's BFnet 0. Okay, where did you create bfnet0.sp? It'd be somewhere earlier.
Yep. Right here.
Ah, okay,
BFnet
great.
0.
All right. Right after that, I'm going to have you, okay, once again here, you should have the code in there for creating fnet0.sp too. So all you have to do that is you have to copy the first 2 lines of that chunk there.
Yeah.
But just replace bfnet0.sp with fnet0 and snet0.sp. Yeah. And yeah, Okay, and then save your script. All right. What I'm going to do is I'm going to send. No. Yeah. Go. Well, you don't need to. No, because FNet 0 SP already exists. But now at least you have a complete set of code there that shows how all of those networks were generated, right? So just go ahead and save the script. You can just click on the disk, the diskette, but either way. Okay, now I'm about to send you, okay, all everything. All right. Okay. So I'm sending it to, do you want me to send it to your DePaul account or your Gmail account?
DePaul is fine.
Okay. Okay, so literally all you will have to do will be to copy this code and then paste it after that, the chunk that creates fnet0.sp and bfnet0.sp and everything. Just paste it right after that as the next chunk and then run it.
And John, just for our viewers, could you just explain the setup R versus the run RS, just to kind of help people understand that how these two things are related?
Well, it's just a matter of how you parse what's in different scripts as a way of keeping yourself organized. What I like to do is, this is kind of a workflow that's evolved for me over time, is I like to have one script which sets up all of the, well, ultimately, all of the R-Siena data objects and basically non-model specific, but just data objects that I might ever want to use. There aren't so many commands involved in doing that the script is going to get enormous and out of hand. So I can afford to keep those all in one place. And that's nice, which means that anytime I want to go see how I defined a particular variable, I can go back to that script. But then I create a separate script for every analysis, basically. And the term analysis obviously is kind of vague and subject to interpretation. But roughly speaking, for what that means to me is that anytime I create a data object that's different from one I used before, I'm going to make a separate script for that, like I was telling Ted a short time ago. And that's what goes into a run R-Siena model script. And I'll have some kind of an indication along there indicating kind of how this particular data object and then the analysis I'm going to do with it differs from other ones that I've used or might use in the future. And that's what the .2FR in this particular one was supposed to convey, that this is an analysis of the two basically nested friendship networks of either close friend or friend versus just close friend. Okay? So basically the setup scripts should contain defining code for all of the variables that I might ever use in a stochastic actor model, generally speaking. So it's the basis for any analysis I'm going to do going forward. But the run R-Siena model scripts are more analysis specific, starting particularly with the data object, which will include the variables, the sum total of variables that I could use in any subsequent analysis addressing that data object. Since unlike other methodologies, in R-Siena you actually have to, you can't just have a bunch of variables lying around in some format as vectors or as parts of a data frame or something, you first have to make them into different classes of R-Siena specific data variables, okay, that have some properties that R-Siena needs in order to figure out what to do with them. And then you have to combine them into what they call an R-Siena data object. And that is and when you use that data object, you only get to use the variables in that data object as part of your modeling. So those and only those can be part of the model. Does that help?
Sure.
All right, Ted, how are we doing? Do you have the that email yet?
I do, and I wasn't sure if you want me to put this in the run.
Just literally copy and paste it, and then put it in a separate chunk right below the one that creates the FNet0SP, BFNet0SP, etc.
Right.
Give it a, yeah. Yep. All right. Now, just run each one of those. Now, what we're doing here, just to let you know, is we're transforming the networks, and don't forget the AdVnet one. You missed the last one. No, the one above it. Yeah. Okay, great. So, so now, if you look up in the workspace window, the global environment there to your right, you'll notice that, for example, AdVnet now has two different versions, an AdVnet0.AR and an AdVnet0.SP, right?
Yeah.
And one of them is shown to be a list, and the other is shown to be an array. Also right?
Yep.
Okay. So the difference there is that for the sparse network format is that what you have is a set of 6 social networks represented as a sparse matrix. And a sparse matrix is basically like an edge list. That is to say, there's a line in the data object for every relationship from some I to some j that identifies the I, the j, and the nature of the relationship. So that's an edge list format. On the other hand, the array format is basically, it's just a multidimensional matrix. So you have rows, columns, and what are sometimes called slices or elements, something like that. So the first dimension of this multidimensional array is, rows. The second is columns, and the third is actually distinct matrices. But the whole thing can be addressed with, indexing like IJK, right? So it makes sense to refer to something called AdVnet0.AR brackets 3, 4, 17. Well, not 17, because you only have 6 in the third dimension. So 3, 4, and 7, or 6, I mean, sorry. And that would give you the element at the third row and the fourth column of the 6th matrix in your network. That is to say, the 6th wave social network matrix. Make sense?
Yeah.
Okay. So it's just but for all intents and purposes here, it's not important. Both of these objects represent the same networks using slightly different formats, but the problem is that R-Siena right now has a bug in it where if you try to include multiple networks in a list format, the data object creation blows up. But if you include them as multi-dimensional array objects, you're fine. So that's the only reason we're doing this, is as a workaround for that. So I have to get a hold of Tom and explain this bug to him. It's not a big deal because there's a workaround, but he really should fix it, and I'm sure he wants to.
So John, could you explain to everyone, we're really looking at friendships as a relationship and the dimensions of it, and yet on this particular script, you actually had them checking off the loan and advice seeking, which are two other relationship types?
Well, that's because remember that the purpose of this script, it's to keep a record of how all of the data objects that I might want to use, and which, by the way, are included in that global environment and in the workspace when I save it, how all of those were created. So all I'm doing here is, the copy that I have right now of this base workspace was different, and probably is different now because Ted's been working on it. He's got his own copy of that base workspace. I've got a copy too. But now, having run all of those different script elements that we just put in there, Ted's workspace now has a multidimensional array version of all of the networks, including both of the friendship networks that we have, and also the loan and advice networks. So now Ted's workspace, at least in regard to these objects, is the same as mine. Okay?
Sure.
Even though we're not going to use the loan and advice networks in this particular analysis. But now they're there. And so if in some future analysis he wanted to include them, he could do it.
So are you saying that there might be a time when we want to look at how friendship might be connected with willing to share loan resources or giving advice? So we want to
Sure.
put them together?
What if it made sense, maybe for our next step? Suppose we get some really keen results from this model that has both FNet and BFNet in it, right? I mean, a logical question might be, well, are best friends more likely to have a loan relationship than not best friends? Well, we could then add the loan network on there and look at some effects that would help us understand that. But that wouldn't work the way R-Siena is set up right now because of this bug, unless we had transformed the loan network into a multidimensional array, as we have done, created multidimensional array versions for friend and best friend. Okay, so now we're all set up for the next step, basically.
Great, thanks, John.
Okay, all right. Now we have a few more things, though. We have to make R-Siena versions of fnet0.ar and bfnet0.ar. So what we now have to do, Ted, is scroll down to where we make the R-Siena data objects, which is right here. Okay. So now what we're going to do, hold on a second. Okay. All right, I got it. Darn, I got to send you some more code.
Okay. And you also said I should include just the friend network 0, right? Not just the best friend here, so I could copy this line and do it. You said it's just helpful to have, right?
Yeah, this is a good time to add just the FNet 0 SD code right in front of that, just so it's there. You don't have to run it because it's already created, but now you know where it came from.
Yeah, I just wanted to be thorough with it.
And as we're waiting for John, Ted, could you just kind of go over once again what these different variables are, just so everyone can understand the ones that where you did FNet OSD.
This is the friendship network. This is the best friend. So we took the friendship network that includes close friend and friend. And then we took the friend and left it out of the best friend one and only included best friends in the advice seeking network and the loan network.
Okay, let me know when you get that email, Ted.
Got it. Copy.
All right. What you're going to do is paste this as a chunk directly under that code you're just looking at there, where we have the calls to Siena dependent there for FNet, BFNet, etc. Just put a new chunk under there. There you go. And now just go ahead and run it. All right. So what we have basically done now is we have replaced the previously noted FNet 0 SD, BFNet 0 SD, etc. above with new versions that use the .AR versions. And I thought that was easier than having to go rename everything in the subsequent script. But we'll keep the chunk above, even though it's not actually defining those variables anymore, just to remind us that once upon a time we did do it that way, and that's how it's done. I'm just kind of a little bit, you know, compulsive about that sort of thing. But from now on,
this is array, right? These create the list, and this creates the array.
Say it again.
The top chunk here does the list, and this one uses the array.
That's right. So what we've done is we've replaced the list version. I mean, literally replaced it. So you'll notice we're using the same names now for FNet 0 SD, BFNet 0 SD, etc. Right? Mm-hmm. We've literally replaced those with array versions. There's no loss of generality there at all. And we probably would have done this from the get-go had I realized that there was this bug. But now we've basically fixed it. Okay. All right. So go ahead and save oh, you already saved the script. All right. And let's go ahead on to run R-Siena model.2fr. And now we're going to rerun this, but now with a redefined FNet and BFNet, it should run okay.
So
go ahead and try it.
Is it possible, because the list was running before, that could have made some difficulties with the prior analyses?
No.
Running array? Okay.
No, because the problem is that it works fine when you just have one network defined, but if you have two or more, it throws up for some reason. It wouldn't have created the data object if the same problem obtained. And I mean, I can actually kind of imagine how Tom probably wrote the code here. See, he redid the syntax a little bit for multiple network specifications. And I think he just forgot to do he forgot in his design that it's possible that networks could be sparse as well as arrays. So that happens. I'm sure it'll be easy for him to fix it. But anyway, Ted, why don't you go ahead and recreate that data object. Let's rerun that code there. Yep. Hopefully this will work.
And it's already going to recognize that now it's array, not a list, right? Because we just changed.
Yeah, because we changed what FNet 0 SD and BFNet 0 SD are defined as, right?
Yeah.
So we don't have to change anything there. And yeah, now this is going fine. Yep, and it's reporting to you that FNet 0 is higher than network BFNet 0. Higher in the sense that it is a less restrictive network. So it has more, oh, let me see, is that what I want to do? Hold on, let me just check on something.
Yeah.
Sorry.
At least one thing is in that thing is told you to read.
It might have send a data create. It might have done what we wanted to, but I'm a little. Okay, let's see here. Oh. Yeah. Well, what's funny about this is that I just read a something in the manual.
On page 52? Or?
No, it's fine. This is fine. It's smart. It's smart enough to realize how that these networks are nested. Okay. I was a little unclear on that. I thought there might be a syntactical thing we had to add to the Siena model create statement, but there isn't. So we're good. All right. Now, basically, we are going to specify a bigger and better model. Because of the fact that whenever you create a data object, the dependent variables that you put in it, all will be included in subsequent models that use it. This model is going to have the FNet, the BFNet, and also the RF endogenous variables. Okay, so the question is, how should we start out doing this analysis? Well, my thought on that would be that we just take the default specification, and let's go down to, let's slide down here. We're going to recreate the, okay, the first thing we should do is change print01 report there to be calling dtobj1.2fr, right? And I would also suggest that you change the model name to bfnetmodels.2fr.
Right.
.2fr. That's how we're going to refer to all the objects that are relevant to this model that has the two friendship networks in it, right? So go ahead and run that, and that will create a bfnetmodels.2fr .text file. It does so in the file window.
Yeah.
Okay. Why don't we go ahead and take a look at that? We have to find it first. Okay, scroll to the bottom. It always puts it there before, unless you click on the name thing to sort it by name.
Yeah.
No, the next one below. There you go.
This one.
Let's just open that and take a look at it. All right. So let's look at the data input. You can see there's 6 observations, waves, 627 actors, 2 dependent network variables, right? Friend and best friend. No bipartite variables, that's irrelevant. There is 1 dependent discrete behavior variable, that's there.
Okay.
And we have 3 constant actor covariates, and we have 1 file of composition change. Correct. Everything good?
Mm-hmm.
Okay.
So
Now we can go.
John,
What?
in terms of dependent variables, we're basically building this without the recovery factor, I think.
No, that has the recovery factor in it. Remember up there it said 2 network dependent variables and 1 behavior dependent variable, and the behavior dependent variable is the recovery factor.
Got it. Okay.
Mm-hmm. Okay. Go ahead and scroll down, and this is giving all of the out degree values for every well, let's see which. Well, it would be doing it for the friendship network, because that was our first network that we specified. So you can see, you know, the first guy has 5 out degrees, the second guy has 5, the third is 6, blah 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 blah. Okay, so you can see that this is going to be a pretty dense matrix.
And John, can you just tell people out degree versus in degree, just real quickly?
Out degree is if I choose you as a friend or close friend. In degree is if you choose me as a close friend. Okay, so the number of my out degrees is the number of people I choose as a friend or close friend. bearing in mind here that these numbers are limited to other people in your same house. So the largest number here can't be bigger than the largest number of individuals in any one house minus one. You can't choose yourself. So this can be useful in some respects, but it's not really important to peruse it at great detail. And why don't we just scroll over it and get to the next stuff? And we have some structurally determined values there. All that means is the structural zeros we put in, which prevent a relationship from being created between two individuals who aren't in the same house, which we wouldn't want. And there's information. This will be information on missing values. This would, by the way, if you had you'll notice that it's kind of an awkward format, but like these numbers all name the actors in order from 1 to 627. And the numbers that you see below them, starting with the zeros, are attached to each one of those 627 individuals. You can see there's very little missing data, right? There's a few ones here and there.
And the rule of thumb from the manual said you can't have more than 20% missing data, right?
Yeah, it depends on a lot of stuff, but in general, it's a bad idea to have too much missing data. And what too much is, it just depends, We're obviously in very good shape here, you can clearly see.
So John, what do you make of, when is the problem there's too much missing data? Is it, at what point do you say you can't use the data?
Oh, it really depends, Lenny, because basically the more complicated your models, the more the missing data hurts you. So, you might be able to estimate pretty simple models with 20, 30% missing data. But if you want to have a complicated, and therefore more accurate model, you really should not have more than, I would say, 5%. And less than that would be a good idea. So it's actually, this isn't fundamentally different than any other statistical modeling situation, except to say that my experience is that these models don't work very well if you have a lot of missing data. And I would say 20% would even be pushing it.
So John, there were some people in the house who didn't participate.
Right.
And how did they get counted?
They're not. They never even show up on the list of 627. And what we would have to do would be to assume that those people are reasonably well represented by the other people who did participate. Basically that assumption in ordinary statistical language is known as missing at random. Technically speaking, there are two levels of that. You can have missing completely at random, which means that literally somebody missed the survey for reasons that had nothing whatsoever to do with any of the other variables in the study. For example, they got sick, or something like that. Or they just accidentally missed signing up, or, something of that sort. That's almost never 100% met in any data set. But it's more plausible to argue that the data is missing at random, which means that conditional on the predictors you have in the model, the data are missing completely at random. All right. And that conditionality means that if your data would be correlated with and predict missingness, then you've somewhat accounted for the missingness, basically. One of those things that is difficult to test, even though theoretically there are tests for these kinds of things in data sets. There's a whole literature around that stuff that we don't have to worry about right now. Again, it's one of those things, Lenny, where the fewer non-participants you have, the better. And we did quite well, right? I mean, our study had signed up, what, over 90% of House members?
Yeah, there were over 700 residents in the study in these 42 houses over the waves over about 2 years. And yeah, kind of over 90% participated.
Right. I think almost any network study would be thrilled to have numbers like that. Okay, so anyway, let's scroll past all this stuff. You can just, scroll like crazy, Ted. There's nothing we really need to look at here. I'll tell you when to stop. Okay, let's scroll up to where all this new stuff starts. All right, now down a little bit. Sorry, all right, right there. All right, so this is giving us some data on the different variables we have here. So we have a dependent actor variable. That's our recovery factor. And it's giving us the number of missing cases per observation. It's actually quite a bit of that, only because we don't have all 627 individuals in all waves, but there's nothing new about that. It's showing us the means of the recovery factors, which you'll notice are slowly going upward. We've actually seen evidence of that from some of Mike's studies, right? Going on down to the constant actor covariance, that's just giving us the frequency distribution. Well, first of all, you've got missing data, and that's quite modest. Covariate information, that's fine. This is information on who leaves and who joins the network, and as you can see, there's a lot of leaving and joining, but really we don't have to worry about that in detail. But it's nice to have a record of it, I guess.
All 627.
All 627, yeah. Okay, hold it there. Okay, now you're seeing the missing data for the and structurally determined values for FNet and BFNet, and it's very low, so that's great.
This part that I'm circling
Yeah,
here?
that's giving you the proportion that are missing, and it's like less than 1%. A third of 1% and a tenth of 1% roughly. Okay, keep going down. All right, hold it right there. All right, so this is for friendship network. One thing that I always look for here, this is showing you the changes from a relationship to no relationship during each interwave period. So from period 1 to 2, we have 391,000 relationships that stay 0, or probably structural 0. 317 that go from 0 to 1, 593 that go from 1 to 0, and then 229 that stay 1. And the Jacquard on that, which is basically a measure of stability, is 20%. So only about 20% of the relationships that existed at time 0 are still there at time 1. We usually like to think of 20% as kind of a lower limit on stability, and it shouldn't be lower. And so that could be a problem. The fact that we have, for example, the change from 2 to 3 as a Jacquard of only 0.126, that's really lower than we'd like. 3 to 4 is probably okay, and 5 to 6 is probably okay. By itself, this is not a ruinous problem, but it could require us to, it could create some stability problems in the estimation. So right now, there's nothing else we can really do about it or say about it. It just kind of is what it is. But we'll just keep that in the back of our minds. Okay, let's scroll on down to see what those look like for BFnet. Well, interestingly enough, the BFnet values are very similar.
Mhm.
Look at that. The Jacards are, I would have thought they might be higher, right? Because best friends are more stable, but no. Not really. That's kind of interesting in and of itself, isn't it? I mean, it's telling us a little something about the friendship network that would be different than if we've had quite high Jacards, like most people who are, who say they're close friends. If there's another observation on them, we'll still be close friends. But that's not really the case. And these values are pretty similar. So that might lead us to think that actually well, to me, it opens a question as to exactly what a close friendship really is. It doesn't open it, it just leaves it open, I guess. Whereas otherwise it might have told us something. I don't see that this is very clarifying in terms of the nature of close friend to most of these residents. It doesn't mean it doesn't have a meaning, it just means that this statistical stuff here being similar to the best friend stability doesn't really tell me anything about it. Okay? All right, well, we could go on. We don't have to bother with this right now. You can just close this if you want to, Ted. But these are the sorts of things that are nice to look at before you start a run, just to give you a general idea of what the data have in them. And sometimes it's not really very important, and other times it is. All right, so let's see here. Next, we're going to create a new effects object down here at the fobj1 chunk on line 76. But of course, we're going to change that to fobj1.2fr. We're doing that with everything. And we're changing that spec there to add 2fr. And we're running that.
Okay.
And now we're going to go ahead and create the effects documentation in the next chunk. Also change that name. Go ahead.
Just that part, right?
Yep. And now we have a new file called fobj1.2fr over there in the, yep, there it is. So let's just explore through this here. First thing I want to show you is that the name spec there has FNet0SD, because that's the first network we specified. Now there will be a whole pile of effects associated with FNet0SD, just like we have for any network. But then we'll have a whole duplicated set of effects for BFNet0SD, okay? So this is going to be like twice as big as the effects object you created before, okay? If you want to, you can scroll down and see what I mean. That short name will, that name spec will change to, there it is, okay, it's already BFNet.
That's where it started.
Yeah. Okay, great. So it starts on line 1313, and if you compare that to the first 1312 rows, they'd be the same, except that BFNet0SD is the name from 1313 on, and FNet0SD is the name from 1312 up. Okay? And this will be relevant because, you know, when you specify, for example, a transitivity effect, you're going to have to make sure that you tell it whether it's a transitivity effect in the FNet network or in the BFNet network. Whereas when you only had one, it didn't matter. Okay. Well, we don't have to have that open for now, but now you know where it is anyway. Hopefully this is all starting to sound a little repetitive.
Yeah, I'm starting to get a little bit more of a handle because now
Right.
we've done this so many times, I kind of know what to expect from certain.
Great, that's great, okay. Okay, so let's keep a scroll in here, and we'll go down and see where the next thing is that we're going to do. which is going to be to create the model object, which is somewhere around line 130 or something.
This one, right?
Keep going. Oh, there it is. Okay, so rename that rf mod.2fr and put a .2fr on there too. And so when you go looking for results, there'll be a text file called bfnetmodels.2fr.
Mm-hmm. So do I change this one too, John, here for?
All right, now what you're going to do here is you're going to, this is going to be a, oh, by the way, I'm just having a little brain fart here. Did you have, did we name the look at Siena data create, or not the pre-01 report line, which is up further. Here we go.
This one.
Right. So we want to name the file that we're going to get from the output and that we create here and here something different. How about model results? BFNet model results. .2fr. Great. So now you're going to have a file called that with .text on it, and that's where all of your results will go. All right. So now wait a minute before you do anything. What we're going to have to do is we're going to have to change one line below there. That is the model type. Okay. Right now, that vector that begins, which is indicated by the C, right? The C notation means you're creating a vector. All right. It's going to go from having one element in it to two. And guess what the first one is going to be? It's going to be fnet 0 SD equals 1. So right before that BFNet spec, but right after the parentheses, write fnet 0 SD, small f, SD equal 1, comma. Okay, that's it. What we have now
because we
done,
have both factors.
we have, yeah, basically what we have done is to tell the algorithm, we've got two dependent network variables here called fnet and bfnet, and they're mode type 1. That is to say they're unimodal networks. There's only one type of node here, individuals. If it had been two, it would have been a bipartite networks, which have individuals within groups of some kind, okay, like individuals within organizations, which is another way you can do these models. And we still only have the behavior model type with one element in it, the recovery factor. So now we can run this chunk. Point, and it helpfully tells you where the results will be. Yay. All right, let's scroll on down here and look at, right, before you get too much further, let's scroll back up to where we start having it include effects. There we go, right there, okay? All right, so you'll notice that first statement, fobj1, well, first, in the first place, you're gonna have to change all of the fobj1 statements there to fobj1.2fr. You can use a, yeah, there you go. Yeah. Yep. I'll just replace them all.
47. Is that right?
That's fine. Just make sure that you don't, you haven't done the same thing earlier. Scroll up and, because, you know, if you have fobj1, yeah, see what you did here in line 76? It was nested.
Yeah, here
So
too.
that's what you really want to, yeah, you don't want to, universal search and replace like that has that danger.
Yeah, that's happened to me several times.
Or you can fix it.
Oh, I had like a letter or something, and then I'm just.
Yeah, there's no effects objects above there, so you're okay. I think that's the
Okay.
only one.
Those are the three.
Yeah. All right. So that looks good. Now, what you're going to want to do here, we're not going to do it on this run. We're going to add the trans-trip and cycle 3s for the 2 friendship networks next. But what we're going to have to do is have 2 include effect statements, one of which adds name equal fnet0sd, and the other one of which adds bfnet0sd. Okay? So let's just go ahead and make those, even though we're not going to add those effects right now, because we want to let this model start with a simple specification. Go ahead and click on change the statement in line 178 there, just before it says trans-trip.
Yeah.
Okay, put in the parameter name equal fnet0sd. Yeah, comma. And now we're going to make another one, so just copy that one.
Should I have that in quotes?
Yes. Sorry, thank you.
Okay.
Well done. Now just make a copy of that, and we're just going to change that line where statement spec where it says fnet to bfnet in the same and just go ahead and add it afterwards. Right, so that's just going to be bfnet. Great. So now, after you finish your next run, hopefully if everything goes well, you'll just add the transitive triplets and 3-cycle effects to both network-dependent equations. And those 2 statements will do it. So you'll notice how before you didn't have to do that because you only had one network. And by default, if the include effects object is not told which network to work on, it will take the first one, in that case the only one, right? And in this case, though, with 2 networks, we're going to explicitly say which ones we want to include the effects in. Because we have to, otherwise it doesn't know. Okay, so just, now let's go ahead down to look at effects.
Want me to run this?
No, you don't have to.
Okay.
Yeah, you don't have to do that right now, because we're not going to add those effects right now to this model. Let's look at what's in the model now. Just run that chunk there. Oh, I wonder if, was it a capital O or small o? That's probably what the problem is.
It's a capital. Yeah. So I did it.
Yeah, there's a capital O. Yeah, when you did your search and replace, unfortunately, you put in a small o to replace it with. So you're going to have to fix that. Okay. All right, great.
These got changed.
Oh, now those all have to be changed too.
Yeah.
Oh well.
Yeah.
Well, you don't have to do all of that right now.
Yeah, you just want to see this one right now, right?
Yeah. Let's just go ahead and look at that. And sure enough, we have a default spec. The recovery factor model only has rate and shape parameters, and both of the networks only have rate parameters and out degree and reciprocity. And we're using the start values that R-Siena created or wants because we had standard inits equal true, right? When we created the object. So now we can run the model. The only thing we have to do is I would say like start, call it like mod1 2fr.1. Yeah, and then get rid of the prevance. Perfect. And now that should run.
Does this need to change or anything? Or these
Oh,
are
I'm
all
sorry. We
fine?
have to add the change RF mod 1 and DT obj 1 to refer to the new versions of it.
To that pod?
Yep. And the same for
And
the
this
data
one too.
object. Yep.
This one's already done. I took care of
And
it.
that's done. So we're good. Rock and roll. We're off to the races.
Yeah, cool. This will take some time.
So that'll grind for a while because it's kind of a bigger model. Yeah, let me know what happens.
Cool. Thanks, John. I appreciate your note.
Yeah,
And that made a lot of sense. I was following along with just about everything you said. The only time I kind of
that's great.
got lost was when you were talking about the array and the list. But I figured like the array just seemed like a little bit more complicated version of a list, where a list was more tidy. But I could be wrong on that.
That's why I like to keep stuff as lists, you know. The thing is, you can have the elements of a list can be any object. They could be vectors, they could be matrices, they could be sparse matrices, they could be other more exotic objects, anything you want. But there they are, nice and clean and with all the properties that such objects have with them. An array, on the other hand, is just a multi-dimensional matrix, and it's just a bunch of numbers. That's all it is. They carry no other information with them other than, you know, how many rows and how many columns and how many individual row column elements you have. So they're very, very bare bones things, and consequently you tend to have to do more bare knuckles coding to find out things about them, to query them and to look at values of them and so on. But they also have a simplicity that some people like, and you know, so, and the same information is being represented, so it really doesn't make any difference. But that's the difference, and yeah. Oh, look at we're already estimating.
Oh, a big here.
Just before let's keep an eye on those deviation values there, which hopefully will be not growing in an unbounded, horrible way.
Mhm. I always pay attention to the biggest one. If it starts going down, it's at a good sign, right?
Yeah, you know, it's if you could average them in your mind, kind of look at them and average them, that would probably be the best indicator. Because a particular one can sort of be big, because what will happen is that the hill climbing algorithm will see, oh, okay, I should change this parameter because that gives us the biggest change in the objective function. And it will keep doing that until some other change turns out to produce the biggest change. I mean, this doesn't look too good. No, it's going okay. It's doing all right. Yeah, see that one. Look at that one.
It bounced back.
Yeah, okay. Yeah, but it started again. Oh, that's why.
Mm-hmm.
See, it realized that it was going off the rails, and then went, oh, wait a second, this isn't good. I'm going to start again here.
So it's
Now it's doing a whole, now it's doing a whole lot better.
Got it.
Yeah, all right, this is going to work out all right, I think. We'll see. You never know for sure.
So
I like that R fixes itself, though, once it starts noticing it's going off the rails.
It's pretty smart. Yeah, it's pretty smart, actually. I mean, that's something that has been developed over the course of some number of years. But yeah, this estimation is looking a lot better. I think this is going to work out okay. All right.
Ted, I'm wondering if you can just pull up quickly the last run you did with close friend, best friend, and we can just kind of real quickly take a look at that output and kind of just show why we were concerned about it so that people can understand what output looks like. We'll certainly get the other output later, but we can at least look at this and make sure we understand what these different numbers mean.
This is the one I did last night, along with the convergence of 1.3. That was the lowest I was able to get it. We had a couple 4s, 3s, 2s, and then I finally whittled it down to 1 when I compared it to the other model.
So John, if we don't get to like 0.25 convergence, kind of what's your sense of that?
I wouldn't worry too much at this point because the model is very incomplete. I would want to add, as we suggested before, the transitivity and 3-cycle effects. If at that point I was still getting lousy convergence, I think I would still press ahead and basically add the effects that I had had, probably one at a time, that I knew were significant for the recovery factor. I would put those in and see if that helped. And then, see, then things get interesting because now we have some effects associated with time in residence. There's an ego effect there. We had some sex effects, some other stuff like that. The question is, does that apply to the friend network or the close friend network or both? And so the way you would look at that is you would start with one, and I would probably start with the friend network. And if I got some good results on that, that is to say it seemed to be a significant predictor there, I would add the same effect or effects to the best friend network and then see what happened there. You know, maybe they'd both be significant. Maybe that would cause one to be significant but not the other, in which case what I would do is I tried the friend but not best friend approach. What about if I try the best friend but not friend approach? And I would see which one was a better predictor. You know, because it might be that they're too highly correlated, you know, in the model as a whole to include them both at the same time. That'd be unfortunate, but it's possible. And so I would kind of proceed with that kind of idea in mind. Try to find out which of the effects that we already know about that seem to apply to either the best friend or the friend networks, which of them apply to only one of the network, if any. In other words, I'm starting to look for differences in the dynamic drivers of each of these friendship networks. Another thing that you will want to do is you will want to include an effect of friendship network affecting best friend network. You can actually include, I think it's called a, I think the effect is called, darn it, hold on. Oh, it's called a CR prod effect. So you can look that up in the manual.
So Ted, do you want to go down to your main effects for this so we can just take a quick look at it?
Talking about this, right?
Yep.
So yeah, so this model doesn't look bad. I mean, if you look at it, most of the effects, maybe all of them, are statistically significant.
So
in that your parameter values, which are the left numerical column there, are more than twice as big as the right column, the standard errors.
And,
so that does,
and just maybe there's the lines beyond above 11, 1 to 11. Would you say that those are the more important ones, particularly the out degree through 11?
Well, they're all statistically significant. I mean, how relatively significant, important they are to the network dynamics, we can't really determine yet, and we can't determine it unless we run some goodness of fit plots, which we're not going to worry about right now. We're still trying to kind of get an idea of what effects are involved. And we have some indication from the lack of convergence that we don't have anything like the right specification yet. Okay, so we're still trying to zero in on that. And once we have zeroed in on that and are getting better converging models, then we can start looking at in more detail at how well the data fit the model, or the model fits the data, I mean. But what we can say is that the effects that we have included in this model here are at least some of the correct effects. Unless we find other effects that we think are more meaningful, that are highly correlated with these, by the way, which, can happen, right? Like you might think something is a sex effect, but it turns out that when you add a variable that varies by sex, it actually ends up predicting better than sex does. In which case it's a better variable because, if you really think about it, sex is not really much of an explanatory variable for much of anything. The question kind of arises as to, well, why do males and females differ on this? That they do is interesting, but the obvious question is, well, yeah, but how come?
So John, last time we talked about specifically density, reciprocity, the triplets, 3 cycles, sex, time. So would you say that those lines from 6 to 11 would be particularly important to look at?
These are effects, the ones from 6, 7, 8, and 9 are effects that you always want to look at in social relationship networks, particularly friendship networks. Now, whether those things hold for loaning and advice is anybody's guess because the nature of those relationships is different, right? Loaning relationships don't necessarily have to be mutual, so that would take care of reciprocity, right? Advice networks don't necessarily have to be mutual either, so they don't necessarily involve reciprocation, right? So if I go to you for advice, that doesn't necessarily make it more likely that you would go to me for advice in any obvious way. Presuming that I'm going to you for advice because you have special expertise. But if there is reciprocity, then that would suggest that going to somebody for advice really isn't about special expertise, wouldn't it?
So for reciprocity, for friendship, basically that is saying over time that reciprocity continues to exist.
That there is a tendency, there's a bias, if you will, that if I choose you as a friend, you're more likely to choose me as a friend than if I hadn't done that. It is also the case, and this is kind of like the dual of it, if you will, that if I choose you as a friend and you don't choose me back, I'm more likely to drop you as a friend later on. So both of those scenarios become more likely. The one that's not likely, if you have a positive significant reciprocity parameter, is that I continue to choose you as a friend even though you don't choose me back. That's the one that becomes less likely based upon that parameter. Make sense?
Yeah.
Okay.
John, I'm familiar with out-degree reciprocity, transitivity, but 3 cycles I'm having. Can you explain that one again?
I'm going to make a suggestion that you read a paper on this because it's really actually kind of interesting. It's by Per Block, and I will send you a copy of it. This guy, he's one of Tom's students from Oxford, and he's now at ZTH in Zurich. And he's a really, really bright guy who, he's just a very thoughtful scientist, Yeah. I could give you a description of it, but you'll learn more if you read this.
Yeah, let me read it, and then if I have questions, I'll come ask you.
Yeah, absolutely.
because that's the only parameter I didn't understand. But I'll read the paper and I'll figure it out.
Oh, Lenny, by the way, are you still recording?
Yes.
Stop recording.
And just,
Can you stop recording?
I could, but I'm not sure I would start up again. So maybe we could, when we finish, we'll have that question. But could I just ask you, for our viewers, could you just give a quick description difference between those two variables?
Which two?
The triplets and 3 cycles.
Well, transitivity is just the idea that if I choose you as a friend and you choose someone else as a friend, it's more likely that I will eventually choose that someone else as a friend too. Often this happens because it can happen because all 3 of us share some interests or characteristics in common that makes us more likely to be friends. Or it can be the case just because since you're friends with both me and that other person, it's more likely that the 3 of us will all end up in the same place together and I'll get to meet him or her. That will potentiate the friendship. 3 cycles are basically about whether relationships of the form, this is funny because it's kind of in a negative way, but of the form I to J to K back to I are more or less likely to form than you would expect by chance. And if the value is negative, it means that the relationships of the form I to J to K without any tie back are relatively more prevalent. And we think of that as suggesting hierarchy in the relationship. Because I chooses J, J chooses K. K is a high status person, and he or she doesn't really care about choosing I, right? So I've referred to this as the Ringo Starr fan club phenomenon, where everybody chooses Ringo Starr, but he doesn't not only choose them, he doesn't even know who they are.
So in this, we do have a minus for this particular variable.
Right, and that's typical when you, and it tends to be interpreted as hierarchy, but there are other possible ways you can think about that, and Per Bloch's article talks about that.
And basically, we have these network variables at the top where we're looking at the social networks, but next to that, under it, we actually are starting to get into the recovery factors. So I'm just wondering if you could just take that one recovery factor, like linear shape, which seems to be extremely, the standard error is small. It's 1.96 if you take column 1 and divide it by column 2, way over 1.96. So what would a linear shape actually mean for that particular recovery factor in relationship to friendship?
Well, the linear shape of it has to do with how the what the objective function for the recovery factor looks like as a function of its own value. All right, and the typical thing that you see is that it's shaped like this. That is to say that conditional on covariance, there will be some unique point that seems to be kind of preferred by most people in the network, all right? And that the tendency is for it to, for changes to converge to that value. But that point can move around depending on covariance, that is to say, depending on other characteristics of the individual besides the recovery factor. So maybe the preferred point is up here for males and it's down there for females or something like that, vice versa. For a better explanation of that, it's a good idea to read the Snyder, Steglick, and Van de Punt paper in Social Networks from 2010. They have a good discussion of that.
So for this, we do see linear and quadratic shape, both being rather significant.
Sure, which is typical. You know, if you didn't see that, then it still could be okay. It just might be that there was no strong preference for individuals in the network to be at a particular value of recovery, ignoring all of their other characteristics. And this is saying that there, actually people who are at different levels will tend to converge to this one special level if you ignore all their other characteristics. So there actually is a tendency for there to be a typical or modal value of the recovery factor for individuals in general. Okay.
So if you were to kind of say close friendship is impacting these types of recovery factors, how would you summarize it based on what you see here? Although we recognize the model is not really perfectly fit.
Well, I would say that you're definitely seeing examples of all of these in the network dynamics part, you're definitely seeing examples of the endogenous network effects that we typically see. So out degree is negative. All that means is that best friendship is a relatively exclusive characteristic. I mean, literally what that means is that you have, since this number of out degree ties tends to be centered, of the number of out degree ties you could have, you have far less than that on average. It also means that if somebody has a lot of them, it's unlikely that they're going to add any. Okay? Or if they should happen to have very, very few, they might add some, but it would have to be very few in order for this effect to be potentiating adding.
When you say adding, you're talking about over time.
Yeah, exactly. This is all about change. Change by adding a friendship, change by terminating one, whatever. Reciprocity, also very strong. So there's a strong tendency for, if one person chooses another as a best friend, the other one will also be choosing that first individual as a best friend. And this is even stronger than we saw for friendship, which we should bear in mind. And we're going to find out, by the way, when the next run finishes, whether that's actually true when we use both networks together. Transitive triplets, once again, really strong effect. So we have strong tendency towards this transitivity in best friendships. There is some hierarchy, interestingly enough. So a best friend of a best friend might not turn around and choose the first guy as a best friend. So that suggests some asymmetry. Basically, reciprocity is an indicator of symmetry. In a way, 3 cycles are a indicator of anti-symmetry. And it's not. It sounds like it's a conflict to say both of those things are true, but it's really not. Both of those dynamics could be possible in a network simultaneously. And then, of course, finally, we have the effects of sex, where we see that females are more likely to make more best friendship choices than men are, right? Because females are 1 on this dummy variable of sex, and males are 0. So this term would not be added to the prediction of a probability of a tie forming for a male, but it would be added to the probability for a female, right? And the same thing is true for amount of time in residence. People who have been in residence for a longer time tend to have more friends, more best friends. No big shock there. Okay?
That's great.
I should mention one other thing that really stands out here. If you go down to the recovery factor equation, the average alter effect is from best friends is not significant. It's positive in magnitude, 0.10, but the standard error is much, much bigger. So that means that either, you might not have expected that. You might have expected that if your best friend had a good score on a recovery factor, that would help you more than just, somebody who was merely a friend and having chosen them as a friend. But that doesn't seem to be the case. The effect size maybe isn't that different. I'd have to go back and look at the result for the friendship network. But part of the problem is that you have so many fewer best friend nominations that there may not be the power to distinguish an average alter effect for best friends. But including the friendship network in the model is going to help us suss that out.
Great. Okay. Well, John, you've been going on for quite a while and extremely,
As I do.
extremely comprehensive and most helpful to people who might want to be getting more information about the interpretation of these outputs. So thank you so much. And
Let's hope.
at this point, we're going to sort of stop the recording and, but hold on one second.